You're welcome back to chemistry class. And then the topic of concern today, even though it's a short topic, a larger topic or a broader topic, acid, base, and salt, is calculations on the pH of a substance. So I believe at the end of this topic, if we're given any question as touching to the calculation of the pH of any substance, we should be able to do that. Now, before we proceed, there are some things we need to clarify. What is actually the pH? The pH, the acronym P and H, means the power of hydrogen or potential for hydrogen. The pH of a substance is actually a measure of the acidity or alkalinity of a substance. It is a system, graded system between 0 and 14, used to test or to measure whether a medium or a substance is acidic or it is basic. So, and then that is of a great or huge importance in the study of chemistry. Now, another thing we need to know is that how can we identify a substance that is acidic and a substance that is not acidic, a substance that is basic, such that we will be able to calculate the pH. That we cast our mind to defining elementarily what an acid is. An acid is any substance that, when in solution, gives hydrogen ion concentration or hydrozonium ion concentration as its only positive ion in solution. So an acid is a substance that will behave like this. Hydrochloric acid is actually an acid. It is an acid if, when in solution, it dissociates to these two ions, and then in the dissociation we have H+, which is hydrogen ion, as the only positive ion in solution. So we can affirm that HCl aqueous is an acid because it gives hydrogen ion concentration as its only positive ion in solution. So any substance that behaves this way is an acid. Then we also need to know what a base is. Any substance that, when it goes into solution, it gives hydroxyl ion concentration as its only negative ion in solution. So, for instance, sodium hydroxide is a base because when it dissociates into sodium and hydroxyl ion. So we have it as Na plus 0 OH minus as the dissociation. So this is a base. Why? Because this ion is the only negative ion that is given when it dissociates. So we can say this is a base. Then we can say this is an acid because H plus is only the positive ion that it liberates when it goes into solution. After saying all of this, don't forget we are looking at the calculations of pH of any substance. So how can we know the pH of a substance such that we can be able to say, this is acidic or this is basic? The first thing we need to know mathematically is that the pH of a substance is negative logarithm to base 10 hydrogen ion concentration of that substance, or we can say it is negative to base 10 hydrozonium ion concentration of hydrozonium ion of that substance. Then secondly, we can also calculate the pOH, the power of hydroxide, and it is minus logarithm to base 10 hydroxyl ion of that concentration. Then we also have that the pH of a substance plus the pOH of that substance is equal to 14. Then lastly, we have that the hydrogen ion concentration of the substance multiplied by the hydroxyl ion concentration is equal to 10 raised to power minus 14. So I believe with these four outlined equations, you should be able to solve any simple question as touching calculation of the pH of a substance. So we have some examples to take here. The first one reads that what is the pH of 0.001 mole per dm³ solution of sodium hydroxide? What is the pH of 0.001 mole per dm³ solution of sodium hydroxide? Now, just as we outlined before we wrote all these four formulae, the approach to it is that this substance in question, we cannot directly calculate the pH. Even though we know the concentration of the substance, we can't directly calculate the pH because the substance is not an acid, it is a base. So the first logical thing we can calculate based on this supplied information is the pH of that substance, because this is sodium hydroxide, which after dissociating, it will dissociate into sodium ion plus hydroxyl ion. So it is a base. We cannot calculate the pH directly, but we can calculate the pOH. So because in that, the concentration of this sodium hydroxide shows that 1 mole from this dissociation reaction, 1 mole of sodium hydroxide is given 1 mole of 0 OH minus rather. So the concentration of this sodium hydroxide is the same as the concentration of the hydroxyl ion that we have there. So invariably we are saying that OH minus is actually 0.001 mole per dm³. So I will have to rub the 4 up. So I said we can't directly calculate the pH. It is the pH we can calculate based on the supplied information. So I'll continue from here. pOH of that substance will now be minus logarithm to base 10. What is the hydroxyl ion concentration? 0.001. And mathematically we have it as, this can be written as 10 raised to power minus 3. Minus, using the laws of logarithm, minus 3 times minus logarithm of 10 to base 10. And in logarithm, if you have a logarithm of a number to the same number, provided the number is not 1 and it is not 0, then we can say it is 1. Minus 3 times log 10 to base 10 is 1. So the pOH of that substance is 3. Don't forget, it is not the pOH we are asked to look for, it is the pH. We can recall in one of those 4 equations that pH plus pOH is equal to 14. The pOH of that substance is 3, which is pH plus 3 equals 14. So the pH of that sodium hydroxide is 14 minus 3, which is what? 11. Now, even if I was not told what the substance is, having calculated 11, I can say that, oh, this substance is a what? Is a base. Based on the grade that we showed the other time. As you leave 7, which is the midpoint, and you are approaching 14, it shows that the substance is what? Is basic. It's more of a base. In fact, it is entirely a base sometimes. So the pH of that solution is 11. We can take another example, and I hope you are getting this as we are going. This other example is rather a long one, but we just have to solve it. And the question is, the pH of a solution obtained by mixing 100 cm cube of 0.1 molar solution of a HCl solution with 100 cm cube of a 0.2 molar, the concentration of the acid conc of HCl is 0.1 molar. Then volume of HCl is 100 cm cube. Then of NaOH is 100 cm cube. The conc of NaOH is 0.2 molar, and then the volume of NaOH is also 100 cm cube. This question is a very fantastic one. There is a special type of reaction in chemistry that we call neutralization reaction, and primarily you have it when acid mixes with a base. It forms salt and water. So in this case, we have HCl mixing with sodium hydroxide. It will form NaCl and water. So what the question is now asking us is that what is the pH of what will be formed? This is the solution formed at the end of the day. What will be the pH of that solution after you mix HCl and NaOH together? So we should be able to determine whether the product will be acidic or basic, because look at it, we have salt and water here, and there is nothing acidic or basic here as it is written on the board. But according to the information supplied, it might be that part of the products will be acidic and or part of it will be what? Basic. So in order to determine whether the product will have little acid or little base, such that we will be able to calculate the pH, we need to know which of the reactants that is in excess. If acid is chloric acid is in excess, it means the product will actually be acidic slightly. Then if sodium hydroxide is in excess, it means the product will slightly be basic. So from our basic mole concept, we know that number of mole of hydrochloric acid will be conc of hydrochloric acid times volume of hydrochloric acid in dm cube. So what is the concentration? That's 0.1 times the volume in dm cube will be 100 over 1000. That will be the volume in dm cube. So we can say that by the time we multiply everything together, we have the number of moles of acid to be 0.01 mole. Don't forget, the reason we are calculating the number of mole of the acid is to and the base is to determine which of them is in excess, such that we spill over to the product. Then we also can calculate the number of mole of the base. That also will be conc of the base times the volume of the base, also in dm cube. So what is the concentration of the base? 0.2 molar, and then the volume of the base is 100 cm cube, but we need to convert it to dm cube. So at the end of the day, after our conversion, we have it that the base is 0.02 mole. Now, looking at our equation of reaction, in the equation of reaction, we have it that 1 mole of acid is reacting with 1 mole of base to form 1 mole of salt and 1 mole of water. So, looking at the mole ratio, it is obvious that the base is in excess out of the two reagents. The base is 0.02 mole, while the acid is 0.01 mole. So we can get the excess number of the one that is in excess will actually be unneutralized, and the unneutralized volume will add up to what we have in the product side, and that is what will now make the product acidic or basic. In this case, it will be basic because we have X mole of a base more than that of the acid. So number of mole of unneutralized NaOH will now be number of mole of NaOH minus number of mole of acid. That will be 0.01 mole. So that we have 0.02 mole of sodium hydroxide reacting with 0.01 mole does not mean that the entire 0.02 mole will react. No, it will only, since the mole ratio is 1:1, it will only react with 0.01 mole of HCl will only react with 0.01 mole of NaOH. So we have 0.01 mole of NaOH in excess, and that will appear in the product side. So definitely the product is basic. So, and the question is, what is the pH of the solution formed? So this is just one step to where we are going. I will have to rub this off so that we can complete our solution. Now, for me to now know the pH, I need to know the concentration of whatever substance we have at the product. So I can say the concentration conc of the resulting solution will be equal to number of mole of unneutralized NaOH divided by the volume of the mixture. What is the mixture in this case? Hydrochloric acid and sodium hydroxide. So what's the number of mole of the unneutralized base? That's 0.01 mole divided by the volume of the mixture. Don't forget we have 100 cm cube of HCl plus 100 cm cube of NaOH. So at the end of the day we have 0.01 divided by 0.1 plus 0.1. So we have 0.01 divided by 0.2. 0.01 divided by 0.2. So this will give us 0.05 mole per dm cube. So the concentration of the resulting solution will be what? 0.05 mole per dm cube of the excess substance, which is the sodium hydroxide. That is not our final answer. Our final answer is to get the pH of the resulting solution. So we now know that the resulting solution will contain this molarity, this concentration of NaOH. So, and we, since it is NaOH, that is, it is a base, we cannot directly calculate the pH. From this information we have got, this is the hydroxyl ion concentration, which is 0.05 mole per dm cube. So we can say the pH of NaOH is minus origin to base 10 hydroxyl ion concentration. So that will be minus logarithm to base 10 of 0.05. That will be logarithm to base 10 of 1 over, I can write 0.05 as 5 over 100 raised to power minus 1. In logarithm, if we have this condition, we can move whatever we have here and place it on the number here. So this 5 over 100 is 1 over 20 raised to power minus 1. So if I take the reciprocal, I have it as log to base 10 of 20. So what is logarithm to base 10 of 20? Pressing our logarithm table is 1.3010. So the POH of that resulting solution is 1.3010. Then finally, since it is not the POH we are asked to calculate, we can end our calculation here. We have that pH plus POH equals 14. So the pH of the resulting solution plus the POH, which is 1.3, approximately, let's approximate it to 1.3 equals 14. So we can say the pH is 14 minus 1.3. Then finally, the pH of that solution is 12.7. So the solution, if tested, will actually test that it is containing slight amounts of a base. I believe with these two examples we have taken, though the second example is long, we've been able to see the impact and the essence of the calculation of pH of a substance. Thank you. See you in the next class.